Let's get started. Welcome everybody to Defender Fridays. Usual quick pitch. Essentially, we get to talk to all kinds of interesting people working on all kinds of interesting things on the Defender side of the equation in cybersecurity, and we just want to make that circle a little bit bigger, have those conversations with more folks, and so. The idea here is really not about slides or anything like that. It's really meant to be kind of an interesting discussion with somebody doing something new we've never heard about, kind of thing. In this case, I can't say it's something we've never heard about. We, at least at Lima Charlie, we've built an integration with Strelka, and so we've got Josh with us today. And I kind of spoiled the punchline here. Talk a little bit about Strelka, but Josh, do you want to do a quick intro?
Yeah, of course. I'm super happy to be here and talk to you all and share about this. So I'm Josh Liburdi. Just to tell you a little bit about me. I've been in the industry doing security engineering and security response kind of work for over a decade. I'm over at DoorDash now as the principal engineer supporting their cyber defense security operations organization. We're hiring. So if you're interested in joining us to build great things and build out the team, I would take a look at our careers page. And yeah, today, I'm super happy to talk about Strelka because it's funny enough. I was looking at the repo. It's almost 7 years to the day that it went open source. So I was like, wow, I should write a blog post or I should do something, right? Because it's still there. It's still being used in a big way at like companies like yours, but also like big organizations. So great timing here. So I think that's me and I'm excited to talk to you all.
Awesome, awesome. Let's probably begin at the beginning a little bit because I feel like Strelka is one of those things that either you know very well what it does, or you maybe haven't heard of it because it's not. And maybe that's my spin here, right? But it's not like the intro tool somebody uses on a weekend just for fun. But it's really powerful. So, do you want to maybe intro Strelka a little bit more?
Yeah. Yeah. Strelka is, what did we call it when it first launched? Enterprise scale file scanning, I think. And there's history there that I think is worth diving into that we can do that. It is not the first tool of its kind. It is like an evolutionary kind of system, but I see it as being not a first priority kind of visibility data collection tool. That's usually your EDR or your network monitoring kind of thing. This is more of a support function for those other tools. But what it does is it takes a file, assesses the content, the file format, that kind of thing, and basically just rips it apart and turns it into metadata. Um, so if it's a zip file, right, it's unzipping, it's then reading all the content of that zip file, it's taking a binary in that zip file, it's going down to the libraries in that binary, and it's really focused on just turning like raw content into metadata that you can use to assess, malware, pull new indicators that no other tools have access to track attackers. There's some really creative uses for it that I think we could talk about that like I don't think anyone even really knows about. Um, but that's what it is at a high level, and I definitely see it as being a tool that is, and conceptually, right, file detection and response, like it's just not a thing that really exists in the industry. It never really caught on in a big way. And I have opinions about that, but um, it's like everyone who uses it, they love it, right? But not everyone knows about it. So.
Nice, nice. And I feel like you kind of hit the nail on the head with uh what you described is the what it's doing, but the how are people using it and leveraging it. And it's so often like that with powerful tools in cybersecurity. It's
Mhm.
like, yeah, here's a really powerful capability, but you know how do we actually use it? Where do we want to think about it in the stack? Do we want to automate off of like all of those things? I'm curious to get your take on that.
Yeah, it's really funny because I really like tools that kind of just let the fire hose loose and just slam you with events and then you kind of make sense of it later. It's one way to kind of approach the problem. As a tool builder, I like that, right? As a user, you have to be like more thoughtful about, how you use it so you don't overload your team and all of these things. But, originally that use case at Target was catching malware coming in through phishing, right? So really easy use case. Everyone has this problem, right? Maybe less of a malware problem today in the current threat landscape with phishing. It's more social engineering and links and things like this for delivery. But it was a big problem back then for like every company that exists, right? That was that time when like, VB script and Microsoft Docs was like a big attack vector for gaining access to an organization. So, um, and then there's companies like Sublime Security. They like very like openly run Strelka in their email security product, right? I think it's amazing. It's the easiest use case to start with. Um, but there's others, right? So you take like I'm just speaking from, purely what's open source, what you can kind of just shortcutting you on what you could grok if you read a bunch of public documentation. But, systems like Suricata or Zeek, right? They can access files, download them to disk. You could send that through a system like Strelka. Live response toolkits, right? When you go to access file content, you could process it locally on the system, or you could how Strelka works is it centralizes it back to like a server to do all the processing. So those are the two big use cases for endpoint response, and then also like network forensics. Um, I know there's teams using it for just pure malware analysis. Hook it up to like a stream of file, I don't know if VirusTotal still gives like a lot of companies access to just the pure file stream of like, hey, here's a link to the every file we're scanning right now. But you could just add on to that, right, and build your own scanner on top of it. There was a time when what can I tell you about more interesting use case? Do you know Socket, the Socket security? They do like third-party package like inspection. Really interesting company. Years ago, I mean, probably like 6 years ago at this point, I had thought about kind of doing something similar with Strelka, which is just like let's just like download everything that's being uploaded to npm and pip and just scan it and see what it does to get those like lower level like indicators of like malware and malicious packages being uploaded. So I think there's like when you think about your like enterprise at a data level, it's packets, it's operating systems with processes running on them, and it's files, right? It's just all that at the lowest level. So that's kind of like where I always saw a project like this going is just build the thing that is like a network, like NSM solution, or build the thing that is like an EDR for files. And I never stayed at Target long enough to actually do it to truly fulfill that vision. I do want to call out the team that's there now. They're still supporting it. They're doing a great job from what I can tell. I check in occasionally on the open source and I'm like, yep, glad to see this is still being maintained and being used and loved in the community. But that's kind of like how I see it, like big picture, right? Is that this is a big opportunity to kind of do more in the file analysis space at scale.
Did you do you if you're okay with like talking about that uh end up using it more as a source of alert, or are you using it more as a retroactive like we're investigating this thing on this box, let's go and see all the files that were collected there, what happened with this and that?
Yeah, if I had to categorize it, I'd say it starts as a threat hunting tool in the sense of like any like a in the sense that an EDR kind of tool could also be a threat hunting tool, like more on the detect side, less on the respond, and same for a network security monitor tool like a Zeek or a Suricata, like Eve logs, right? If you know what those are. Um, I think it starts with the data collection and then you layer on the use cases after that. So yes, I've seen teams build alerts off of it, right? Like off of the data feeds. Um, I think I haven't seen it used personally so much for like retroactive analysis, but you can certainly do that. Um, I think what I've like that would be more like from my point of view, like if I have a binary, right, and I don't want to submit it to VirusTotal, or I don't want to submit it to Joe or any run or whatever, right? I don't need the dynamic analysis part. I might just pop up a Strelka cluster locally on my system and run it through there just to see what it can tell me. Just kind of like short circuit the static analysis you might do as an analyst. So I think it's pretty flexible from that point of view. The downside is, it's verbose. I mean, you can tune it. I mean, what we're talking about here is like turning like file content into metadata. So you need to it's like any really great security tool where it's like a foot gun, right? It's blasting you with data, and if you don't know enough to actually make sense of it, it's not going to help you. I think that's the gap with a tool like this. It's like you wouldn't just give like an intern like a 10 gigabyte like PCAP file and say, here's Wireshark, find the evil in it, right? It's kind of like that. Like that won't go well. So you have to spend a lot of time with it, I think, to really get use out of it.
Yeah, I suspect it also makes it a little bit harder for some folks to get started using it because it's not one of those tools where you can say, "Hey, you deploy that. This is the clear outcome thing you gain from it," right? It's kind of a somewhat nebulous capability unless you are a target, right? Where you can say, look, we've got like a large team is a core piece of infrastructure. We're gonna do a bunch of things off of that.
Yeah,
Um,
I think that's true. I think it's not a tool for your day one team, right? It's a tool for your day thousand team at best. Like at Target, when I worked there, I won't make any commentary about, things that have happened there that are non-public, like that are private, but I joined that team at a time when they've already hit their stride from a maturity point of view. They'd already put all the basic like I don't even want to say basic. They put all the processes in place they needed to do to secure the company and do their job of defending the company from a cyber resilience point of view. So I joined them at a time when they were actually in more of an exploratory mode. They'd already built some projects that are not known publicly that are like very impressive in my opinion. Strelka is just one of a couple that went open source. So the mandate when I joined was like, hey, figure out how to do like malware, like really in-depth malware identification through phishing. And that was kind of how it got started. Um, but I think to speak to the use case, the immediate use case really is that hook it up to your data feed to your systems you care about, like your phishing identification. It could be your live response, whatever it may be. And that it works really well when you have a good sense of who your threat actors are and you're really good at indicator tracking. Because what this thing does is it turns file content into metadata in such a way as to generate a new type of indicator. You're able to track indicators that really no other company who doesn't run this can track. And I'm talking about things like who is the author of a document? How is this document created? Like these are like different kinds of artifacts that you can use to identify attackers that they probably think about to some little extent, but they don't think that there are organizations that can actually use that as a detection mechanism, right? And that is really what it's all about is surfacing those artifact patterns up to the team so they can make a decision on how to operationalize all of their intel. Yeah. But which is to say, all very mature organization kind of stuff, right? Like if you don't have an intel team, you don't know who your attackers are. This thing is probably not going to help you.
all right. I forget. Does Strelka come with a like you're generating all of this metadata? Does it come with a optimized storage area to query or generate statistics on any of that stuff, or is that kind of
Hmm.
decoupled in a different?
Yeah, no, it's well, I honestly I can't really say what they might have added at Target. They've added something. I think they've added a UI to it, which was very impressive. Haven't used it, but I was like, wow, I would have never thought to do that because I'm not a front end person. Um, but no, it's really like a data feed. It's like a file feed. It's like you run Zeek, you get con logs, you get HTTP logs, and that kind of thing. It's exactly that, and it's choose your own adventure with storage and analysis. You can put it to a SIM, you could put it to a data lake. And that's why I say it's maybe more of a threat hunting tool first, than it is like a out of the box detection tool. But I think it's like any good open source kind of security solution. You could have someone who ships and it's all JSON data, I should say too, right? So you could have someone that writes rules on it, using like JQ or whatever it may be to actually do some analysis queries. I think the thing is maybe it hasn't caught on enough in the industry for that to actually be a thing. It's like a flywheel effect, right? Where, more people use it, so they share information on how to use it, and then it just grows and grows. This is more of like just flown under the radar, I would say.
Yeah, I could see a lot of interesting stuff, doing something like shipping that data into something like BigQuery
Oh
to
yeah.
be able to run, like let that run a year, right? And now looking for interesting patterns in the data, or if something comes up to your point around kind of chaining up like IOCs, to be able to, create a almost like a graph, right, from that initial IOC and kind of blow it up and say, okay, of all the related metadata, which one hasn't been seen anywhere else in the organization or things like that. That
Yeah.
would be cool.
Yeah. I mean, definitely. I don't remember the numbers on it. There's a presentation I gave at B-Side San Francisco, I don't know, almost a decade ago at this point, but it was on this topic, and there were some numbers shared then from the target deployment. It's probably grown, I would assume. But, we were scanning, I think in there, it mentioned like up to 3 TB of file content a day, something like that. I mean, it's it's a lot of data. And it has a really good like you consider it like not a compression ratio, but like a summarization metadata ratio of like taking like it's like 100 to 1 basically. So if it's a 1 meg file, you get it down to like I'm not good at math, whatever 1 KB, that kind of thing. So yeah, I mean it's if you have like a data lake kind of model, if you have like like semi-structured query platform, Snowflake, Databricks, BigQuery, whatever it may be. It's great for that.
Nice, nice. You also mentioned earlier interesting use cases people hadn't thought about. I'm curious, what are the coolest ones that you've seen or you've heard about?
Yeah. I mean, I think like the scanning of public like libraries, right? NPM, like Python pip, that kind of thing. That was one I was always really curious about, and then another company came in and did it better. I think what's interesting is that like there are times when we would deploy it in new areas like business environments, and we would just always learn something new. I think there was a time when we started to get just like floods of like JPEG images. And I was like, what is this? Like, didn't make sense. And then I like open one and look at it, and it's just like a still image of a hallway. I'm like, oh, okay, it's a still image of a hallway. That's strange. And I would open another one because it's in the same kind of like event stream. It's another still image of the same hallway. I'm like, oh my God, this is just like a webcam in a location somewhere, and it's just transmitting its images in plain text. So now we're just getting copies of like an empty hallway. So there's just like really bizarre things that happen when you deploy this at scale. Um, I think there's other use cases too. Like retail is a really unique environment because it's like there's a lot of unmanaged like networks. I don't want to say fully unmanaged. I don't think that's technically accurate, but you have guest networks in a lot of retail locations. So there's a lot of interesting things that can happen there from a malware identification point of view. Um, you know, Someone with a compromised Android device walks into your location and suddenly your indicators, your alerts spike, right? Um, I think that's pretty interesting. I think someone in the chat had mentioned about using it for like client like engagements, like maybe from more of a consulting point of view. I think there's use in there as well. Um, I will tell you that there were moments in development of that system where it didn't what's the best way to say this? I didn't know how crazy the scale was until we actually started to look at some of the data. Like, for example, there's a feature in the system where we will cache values to reduce the load on scanning a file. Basically, the way it works is the front end, the client side is all Go. It uses gRPC to stream data to the server, and then the server back end is all Python for data processing. There was a point where I noticed that we had scanned a file. It was like less than 1 KB. It was like a very tiny file. But we had scanned it like hundreds of millions of times a day. And we had spent, I think, like something like 70 to 80 CPU hours in one day scanning the same file over and over. And the file had nothing of interest in it. So I was like, okay, that's not good. I don't want to burn down our data center. So we should probably just like build a caching system here. And that's kind of like where the caching system came from. I don't think anyone actually knows any of that. So it's like one of those details where it's like, okay, there's a story for every part of that system and why it's designed the way it is. And once we did that, then we just started to like we could really like scale back like how much CPU we were spending cycles on. So
I mean, that's a great segue into like sort of the natural transition in my mind is if you had to do it again, I like would you do it again or how would you make it like different? Do you think there's kind of opportunities that structuring the project in a slightly different way could have been pretty useful or something like that?
yeah, would I do it again? I think if it's hard because the context of the time and place is important, right? It was the solution needed there then, and they still use it at that company and other companies. So I think yes, for that all those reasons. Would I do it the same way? I don't know. And this is probably where it's worth getting into like a little bit of the history of it, right? And that this project actually started as a migration of Lockheed Martin's Like a Boss project, which has not really been supported for quite a while, unfortunately. It's a great project. It's also open source. It started as a fork of that from Python 2 to Python 3. It was a migration project. And I just had so many issues actually doing the migration. And then I just kind of learned way more about how their system worked that I was like, okay, I think we should just do it from scratch, but based on their project. So if you look at the open source, there's actually a license file in it for Lockheed Martin. Um, it also explains the name a little bit because their project is named Laika, which is after the first dog in space, right? The Russian astronaut. Um, this project was going to be called Belka, which was one of the second dogs in space. I think the legal team at that company said, no, we can't name it that for some reason. There's like another trademark on that name. It's like, okay, we'll call it Strelka. So that explains the name. So there's actually a lineage in the name. It's kind of a homage to the team at Lockheed. But from an actual code point of view, I think you could do it better if you spent more like software dev time on it. Like I think the reason why it's written in Python in the back end is because there's just so many libraries that do file parsing. Like PE file is a really great library in Python to just rip apart a packed executable. But if you did it all in Go, you'd have to be writing your own libraries, you'd be writing your own file parsers. It would take a lot more time. So we wrote the front end or the client side in Go to do efficient file extraction and then and just scale the back end out through horizontally, basically. Um, that's a lot of the technical stuff. There's some like really interesting like things again about working in retail that inform the design of it too, like the fact that it uses gRCP streams. Um, I think there's like with retail, some of your locations have lower bandwidth. So we had to be like very careful in how we actually extract and transmit data over the network, such that we don't want to like actually impede the business, right? Like consume so much bandwidth that they can't like process transactions or things like that. So there's a lot of like nuance in there and how it works. And there was a system to like actually throttle it artificially built into it, where it uses like bandwidth shaping to say like, okay, we're gonna drop the client into a lower tier of data collection, so it's only prioritized on the highest impact files. It's not collecting everything for these low bandwidth environments. So there's a lot of stuff like that. It's really defined by the environment you work in, because at the time that was written too, like it was not a cloud native environment. It was all like on-prem cloud, so to speak. So, in the age of AWS and GCP and serverless, it would probably look a lot different if I did it today. Yeah.
Very cool, very cool. And yeah, that was what I meant by would you do it again, is really, would you do it the same way again? Because like, obviously,
Yeah,
yes, it served a purpose for sure. It's I just found that maybe you feel the same over my career, rebuilding the same type of thing multiple times. Every time you get an opportunity to, fix some of the things that weren't quite like that turned out to be problematic in the past. And so I find it's
yeah.
always an interesting kind of topic.
I will say that I sometimes look at the code base and I'm like, wow, target team, you guys should update this because it is not good. Like, I mean, like this is just, I mean, I know it works, but this could be so much better. I don't know if any of them are on the call or going to watch later, but maybe that's a challenge to you guys and gals. I'm sure you can make it better.
Nice, nice, nice. So if somebody kind of heard today like about Strelka and thinks that like, hey, there's some interesting value for their organizations, like whatever type that is, do you have like tips or guidance of, or like hard earned lessons on how to start that adoption, kind of get on that road?
Yeah. No, yeah, I think we touched on it earlier. It's, what think about how you're doing file analysis today, even if it's not automated, right? Is it malware analysis? Is it, I just need to do like live response, and all the places you could collect files too, if it's useful for security monitoring, like NSM as the example, right? Start there, and then I think experimentation. I'm a big fan of that. Just you can spin up a Strelka cluster locally on your device. I think they even have like a single like Go like kind of like client binary you can run to just do a scan and see what you get. It's a great way to start. A lot of people in this industry, they just have like repos of malware somewhere, right? Or can get access to malware. Put it like scan it and see what you get. I think it's really surprising. Um, and generally, I would just say it kind of changes your opinion about like how you can, analyze files, right? It's at its core, it's just it's like static analysis of files on a massive scale, right? It requires a different kind of like mindset than I'm going to look at VT and I'm just going to get the dynamic analysis output from the sandbox. Um, but yeah, think about your use cases. Phishing is still a threat, I would say. It's a good one. Yeah, that's where I'd start.
Nice, nice, nice. Well, thanks a lot for coming here. If folks want to get in touch with you, perhaps to discuss some more kind of the road to Strelka, is there a better way to do that, or?
Yeah, LinkedIn is great. I don't use Twitter anymore. I'm gone and off that platform. I'm on Blue Sky, but don't use it. So find me on LinkedIn. It's the best place to get a hold of me. And I'm happy to chat. Yeah.
Awesome, awesome. Oh, thanks a lot. That was super interesting. I feel like you were part of history a little bit in a weird way, like part of a pretty big open source project like that. So it's super cool. Thanks for
Yeah.
coming in.
Yeah.
And cool. Well, we will see you everybody next week for next Defender Fridays. Have a good weekend.